Hello, my name is Nada Evans, and I support Dr. Jenkins from time to time in his 45-hour math class. And I'm so excited to give this presentation for you on the Common Core Math Classroom. So let's begin. Today we're going to talk about the major shifts in the Common Core, content focus, the math practices, rigor, what does it look like all together in action? What are some best practices for instruction? And what are the performance expectations of our students in math? So, looking at the major shifts, instead of just going page to page in our textbooks like we were taught, right now we want to help the students make connections across the topics at each grade level. And then as well as we want them to make connections between the topics from grade level to grade level because they really build on each other from year to year. And then we're looking at rigor. And that's a big buzzword right now. And as it relates to Common Core math, rigor is a balance between conceptual understanding, that's understanding the how and the why, and procedural skill and fluency. That was the focus when we were being taught. And application. What is the real world use for this learning? So in the rigor, we definitely are keeping procedural skills, but that's not the focus anymore. They need to understand the how and the why and how to apply it to real life. That is the focus. So let's look at the content now. With the Common Core, and I'm sure you've heard things on the news, we're actually teaching fewer concepts at each grade level to really allow for deep understanding. So let's look at kindergarten. We're going to go from grade to grade all the way through high school. And we see here these three different color boxes. And what do they mean? They're each three different sizes. So in the Common Core, math is broken up into domains. That's your kind of big, broad area. And then you have standards and skills under each domain. And the green is the major content. So those are the areas where you're going to spend the bulk of your time, actually about 3/4 of your time. And the first half of the year is going to be mostly in this green. Then you have the blue, which are supporting standards, and those directly relate to anything being taught in the green. So they really support and enhance what you've taught, the concepts that you taught in the green. The yellow is yellow not because it's not important, not as important. It's yellow because it doesn't directly relate to the major or supporting standards. So I know geometry for many is one of those concepts that is thrown to the wayside, and it's one of those that you really wish to get to but you don't end up getting to. But it's very important to get to, especially at the lower grades. In kindergarten, you're actually understanding all the parts of a shape. In geometry, you're learning the vocabulary of vertex, side, edge, face. All of that is in kindergarten now, because when we get to first and second grade, it gets a little deeper, a lot faster. So here in first and second grade, what do we see? Counting and cardinality is no longer the focus. That domain is actually solely for kindergarten. And the expectation is that it's mastered, so it's not taught again in first and second grade. In first and second grade, you're really working with operations and algebraic thinking and numbers in base 10. We're regrouping, we're decomposing, we're not borrowing anymore. That language, that vocabulary is not in the Common Core standards. It's regrouping and decomposing and decomposing. And we're actually introducing variables in the form of shapes of smiley faces as missing numbers in an addition or subtraction sentence. And here we're looking at measurement and data again as supporting the major standards. And in geometry, it's not related, and it's a little tricky, is that you think you're teaching shapes. No, we are really teaching fractions through shapes. So it's not, you don't see it here, but this is where we're introducing fractions at the first and second grade level. So it's very, very important that we always get to geometry when we're teaching. So moving to third, fourth, and fifth grade, what do we see? Well, now fractions is part of the major instruction in these grade levels, and it's formally introduced in third grade. So what happens if we skip geometry in first and second grade? Now they're 2 years behind already in third grade. So it's very important that we do not skip any of the standards. And by the end of the fifth grade, you're pretty much doing all of the operations of fractions except for mixed numbers and division of fractions. And then again, measurement and data directly relates to everything that you've been teaching in the major standards. And geometry, it just doesn't directly support the other standards, but they are still very, very important. Now, moving into the middle grades, beginning in sixth grade, now the names are changing for the domains. Then we're learning about the entire number system now. We're introducing integers. In sixth and seventh grade, we're working on ratio and proportional reasoning, and we're working on expressions and equations. What's really, really interesting is that in the U.S., students tend to perform better on expressions and equations than on ratio and proportional reasoning. Why do you think that is? Well, expressions and equations are a little easier to teach because it's very procedural. Ratios and proportional reasoning is all about relationship, it's all about understanding, and it's all about application. And what happens is teachers are normally more comfortable teaching the procedural versus the application. So it's really important that we understand these understand this as educators, so that way we can do whatever we need to do to understand how to teach these concepts better. And now what's interesting in 6th and 7th grade is the geometry and statistics. Some of it supports the major standards and some of it doesn't, but it's all equally important. So now let's move on to 8th grade. Look at 8th grade. No more ratios and proportional reasoning. And now we're adding functions. So you see how we're building and we're going really pushing them higher to the next stage at every grade. And now we're still teaching the number system, but they really should have gotten such a strong handle on it in 6th and 7th grade that now by 8th grade, you're not spending as much time on it. And statistics and probability directly support expressions and functions. And then geometry is separate, but it's equally as important. It's very important that students understand the Pythagorean theorem in 8th grade. It's just not directly related to expressions and equations, but it doesn't mean that you skip it. So now let's go to high school. High school is a little bit different in that the standards don't differentiate between major, supporting, and additional. What it does do with the high school standards is it says, okay, these are the concepts that apply to most colleges and college majors and careers. And then these are the ones that are kind of important for college majors and careers. So that's what we see in the green and the blue here. Number and quantity, algebra and functions are the most widely applicable for college majors and careers. And then geometry, probability, and statistics are pretty important. They're pretty important for majors and careers. Now, before we can get to that, however, we have some prerequisites. So these are the concepts that are really, really important for students to be able to apply and understand and apply to be able to work at the high school level. So it's very important that at the middle grades they don't just know how to they don't just know the procedural skills, but they can apply them. You see, all of these are all application. So it's very, very important. So I'm going to list these as separate handouts, and I broke it down by grade level. All of this information is available through the Achieve the Core website. And what you get here is a breakdown of the domains and the concepts within those domains. So I showed you the broad ranges in the green bar, And here it breaks it down a little bit deeper at each grade level. And why is it helpful for you to see this? For a couple of reasons. It's helpful because then now you can look back at what might have been some prerequisite skills that students are missing that directly relate to the concepts that you're teaching. And also gives you an idea of what you should be teaching and when. However, as new teachers to the profession, I would give you one suggestion, and that is to definitely seek support from your content supervisors and your director of curriculum and instruction or your principal as far as what the scope and sequence is for your curriculum. How and when are you going to be teaching these concepts? Okay, so that you've got to really understand from the school that you're in what are those expectations, and many places already have a timeline for you as to what you should be teaching and when. So it's very, very important that you follow those. So the second one is procedural skill. So I'm going to have you take a moment and read this slide. Now, what does this say about fluency? It says that fluency and procedural skills is an outcome of solid instruction, right? So it's important that we have those conceptual activities where students are really understanding the how and the why, and then the procedural skills will follow. And these are the end of year benchmarks for the procedural skills. Students have all year to meet these benchmarks. Now, again, see your curriculum person, your supervisor, your principal to see if they have something that breaks this down a little deeper. Some places might go so far as to, by the end of October, students have facts up to 3 memorized. So really ask the question at the school, at your schools, what are the learning expectations for your students? Let's look at high school. In high school, there's no real set expectations for fluency, but I did find some suggestions to help, kind of guide you at the high school level. So these are some guiding suggestions as to what might be good topics for the students to be fluent with at the high school level. But again, I'll repeat it again. Talk to your supervisor, your department chair, your curriculum and instruction person to really find out what it is the expectations are at the school. So another part of the Common Core that doesn't get too much attention are what's called the mathematical practices. And these are very, very important for you to know and understand. What are mathematical practices? They are the behaviors of a mathematician. There are 8 standards for mathematical practice. These are standards that are written. They are your Common Core standards. However, these are 8 standards that are the same at each grade level. 3 of these standards are assessed on the PARCC assessment. Standard 3, Standard 4, and Standard 6. But you do practice all of these standards. You can't just teach these standards in isolation. And these standards happen at the same time as you're teaching the content standards, because as they're learning the content knowledge, they're going to be practicing these behaviors at the same time as you instruct. And the method that you use to instruct will either facilitate these behaviors or not facilitate these behaviors, right? So clearly, if I'm at the front of the room and I'm lecturing, the students aren't truly engaging in these. So the method that you use to instruct will either facilitate or not facilitate the Common Core standards. It is very important. This is a part of being Common Core aligned. However, the issue is now, well, what does constructing viable arguments look like in kindergarten versus 5th grade versus high school, right? Because they're at completely different developmental stages. So, well, the expectation needs to be different. So, last year I had found these wonderful little posters online, and as a math supervisor at the time, I had these printed out and laminated, and I gave them to each teacher, and told them, I said, post these up in your room, and your curriculum tells you which math practice goes with each lesson. So use it when you're teaching a lesson and it says MP3, math practice 3, then pull that poster up to the front of the room and say, okay, while we're working through this lesson, this is another thing that we're going to be working on. We're going to be working on explaining our thinking and considering the thinking of others, right? Because this is the adult language and this is kid-friendly language. You have to consider, which language am I going to use when I'm teaching? This one is a little far-fetched and students aren't going to really understand that. But the kid-friendly language, that's what they're going to understand. And you're going to say, to explain your thinking, you're going to draw, you're going to use objects, we're going to draw, or we're going to use actions, and we're going to practice that today. And then we can compare our strategies to others by listening to what they're saying, by asking questions, and then seeing what's the same or what's different. So that's what you can do at the kindergarten and first grade level. So let's look at fifth grade. At the fifth grade level, well, what does it look like? So I would say to the students, well, in addition to doing our work today, we're going to make logical arguments and respond to the math thinking of others. You see how that language kind of scaffolds and grows as the students are up, move up. And it says, you can just read the poster to them. But today we can make and present our arguments by using objects, drawings, diagrams, and actions, or we can give examples to prove it, or examples that disprove it, a non-example. And then we're going to analyze each other's reasoning. We're going to listen, we're going to ask and answer questions, and we're going to compare our strategies and arguments. So these are some ways that you can now facilitate, right? Think about what you must be doing as a teacher to get your students to ask and answer each other's questions. This is not the teacher asking, this is the students asking. So how am I going to teach? What method am I going to use to teach to be able to facilitate that? So now let's look at that same practice standard at 7th grade and up. Now we're saying, today we're going to practice making conjectures and critiquing the math reasoning of others. And you would go through it just the same. And then eventually, if you repeat it and you continue using this method, the students, it'll get to a point where you don't even have to explain it. You could just kind of point to the poster. You can even find keep with them, put it in their notebook. There's any kind of idea that you can think of, it's out there. You don't have to reinvent it. But these are Common Core standards that must be addressed at each grade level with each lesson. If you're using a printed text, it will tell you which standard matches that lesson. Other than that, if yours doesn't, I would say you can go online to Engage New York and kind of find the topic that you're teaching, and it'll give you suggestions on what to include in the lesson. There's a free entire curriculum for free on there. It's beautiful. All right, so next, oops, sorry about that. We're going to look at, well, what can this, oh, here we go. Got it. So now we're going to look at rigor. Rigor is one of those buzzwords. If you haven't heard it yet, you're going to be hearing it soon. It's basically making the work more challenging for each student as an individual. And some people think, okay, well, I have this student over here who's faster. I'm just going to give them extra worksheets. Well, you know what those kids think? They think, why am I being punished just because I was able to do this faster than everybody else? Right? So we've really got to think of what is the purpose for the work and how is this going to help that student? How is this going to enrich their learning? So some people think that being more rigorous or challenging is giving them more homework, giving them more to do. Oh, some kids, they're just not there yet. I can't challenge them. And if I support them, that means they're not being challenging. Or I don't have enough resources to be challenging in my classroom. Those are all myths. One, rigor is for everyone. So let's look at this picture. In this picture, we see, imagine that this fence are the Common Core standards, right? And we need to make sure our students can see over that fence. Not that they did just meet them, but they can kind of surpass them. So we want all the children to see the baseball game. We want them all to surpass the Common Core standards for that mastery level. Well, here we go. We've got a child who doesn't need any help. He's good. He's just going along on top. He's easy breezy. But then we have these two here. Well, what does a challenge mean? Well, I need to give this child a stepping block. He still has to climb that stepping block. I've got to give him a layer of support. But if I put this layer of support there, he's now able to climb it and see the game. Now this child here, well, he needs a lot of attention. This baby, he's going to be the baby that's going to be attached to my hip, and I'm going to help him the whole way through. Doesn't mean doing for him. It means giving him the exact help, finding exactly what he needs to be able to reach over those standards. But he's got to do the climbing. I'm just helping him. I'm laying out the steps for him to get there. And some people say, well, then that's not rigor. Well, yes, it is, because that child's still got to climb and meet it. And we've just got to meet the children where they're at. We really do. And I'll tell you a story. When I first started teaching, it wasn't that long ago, in 1999, I also came through alternate route, and I received an empty classroom, barely enough seats, and I had 29 first graders. I had to make it work. I found all my free resources. There weren't a lot of things out on the internet, but there were some, and I made sure I was in constant communication with my principal and the people, my math coach, my literacy coach, the people who were there for me. I made sure I pulled their resources and got the help that I needed. As new teachers, that is very important. Definitely reach out to those resources at your school because that's why they're there. But then also, go on the internet. There's so many free resources online. So this guy, Dan Meyer, he's going to share with you what great math instruction can look like. So let's play the video and listen to Dan.
Hi, my name is Dan Meyer. I taught high school math for 6 years to students who did not like math, and now I'm on a doctoral fellowship at Stanford studying curriculum design and teacher education. So what I'm doing is I'm taking a camera out, a video camera or a photo camera, and I'm taking a picture of that real-world scenario in such a way that the question that's buried at the bottom, in the last step of the textbook problem, is the first thing on that student's mind. I want to make that question irresistible to a student, so they have to know the answer. Then I take that interest and I layer math on top of it. Our goal in my classes is to let math serve conversation, to let math serve prediction and betting and arguing, not the other way around. We don't do all of that to serve the math. So here's an example, is I took a flip camera out, a little cheap camera, put on a tripod, and I shot a basketball shot in front of it. And then I took that video file and I just carved it up and I made this half video where the ball kind of strobes in the air and then hovers halfway between me and the hoop. And that's a good moment because I don't have to ask the question there. You know what the question is. The students are feeling the question. Is that ball going to go in the hoop? And from there, I can take bets and predictions. We all put a guess on the record. I show a few more shots, some that obviously are going to miss, some that may make it. And from there, you want to know the answer. Am I right or wrong? And so I throw you into a simulator where you are modeling the parabola on top of that, and you can see, like, okay, it's going to continue and miss or go in. And the best part about using multimedia in these instances, one of the great parts, is that I don't have to turn to the back of the teacher's edition and tell you, well, the textbook says you're right. Or as the teacher, I say, you're right. We just watch the end of the video. And from that, I can be a co-learner with my students. Like, we're working on it here, and they're asking me, am I right? And I'm saying, beats me. Let's find out. It's a good moment. Another example is the classic boat in the river problem, which students on paper have a hard time wrapping their heads around it, where you have a kayaker going upstream and downstream. So I'm thinking, where can I find an upstream and a downstream in my day-to-day life, and take the camera out there and film it. And it occurs an escalator. I can walk up the down escalator, and that's going against the current. So I take my camera, I shoot it, and then I set the end of the video up in such a way that the question on everybody's mind is, how long is it going to take him to go up the down escalator? You see me pause there, and it's hard not to think that question. And from there, we take guesses. What do you think? 1 minute, 2 minutes, 10 seconds? I'll ask you for, what do you know is a wrong answer? I'll ask you, my struggling learner, for a wrong answer. Give me a number that's too high, that's too low. And from there, I'm involving students at a very low investment that has huge return, because you're setting error bounds on your answer already. Or here's an example. How long will it take to fill up a water tank? You got a hose, it's filling up the tank slowly, agonizingly slowly, and pretty soon you're wondering, man, how long is it going to take to fill this up? And from there, you have to ask a question that is nowhere in textbooks that I've used. You have to ask the question, what information do I need to solve this problem? Textbook usually gives you that information. Whereas here, you've got to ask yourself, what matters? Does the height of the tank matter? Does the flow rate matter? And then we give you that info, you work the problem out, and we can show you the answer. You can fast forward to the end of the video and see how long it took to fill up that water tank. It's a harder and more fun problem than what my textbook offers my students. It's asking them to do more, and they're having more fun doing it. And that's a crazy kind of double win.
Wow. So how is Dan's instruction really reaching his students that don't like math? Right. He's making it interesting. He's making it relevant. He's making them do the work. He's pulling out some of that fluff from the word problems and really making them think deeply as to what is it that I need to analyze to be able to answer this question. He's making it real life, because when you are working on your house or working on your car, there's a problem. The contingencies usually aren't given to you. You kind of have to discover the contingencies and really think about what those might be. So he's making this problem solving real life, and he's making the students work, and they're more engaged that way. So that's what math class can look like, depending on how you construct your teaching and what methods you use to teach.
Hi, my name is Dan Meyer.
Sorry about that. So looking at the PARCC assessment, the PARCC is really great. There's a lot of information on it. You can go to parcconline.org. And here they give you some sample questions in ELA and math. So even if you're not going to teach math, you can get some sample questions here. And I just want to take you through and kind of look at a few of them so you can see the level of work. And this is 3rd through 5th grade sample items. You know, really information they have to be able to find. Let's go to the next one. Here we go. More information. Solve the answer. Put it in there. Now we've got a part A, part B, where they have to model. Select the boxes and shade them. So it's really important that they are familiar with drawing things out in the classroom. And now they have to write an equation for their model. And in many of them, you're going to see boxes of explain how you got your answer. And that's going to be graded. It's really, the assessment really aligns with what the expectations are in the Common Core standards. So that's what we're saying. And your daily teaching has to prepare them for the expected outcome. Because it's not going to just happen from one day to the next, right? You've got to get them there slowly. And how we do that is through our instructional strategies. That is the method that you're going to use to instruct, right? So it's really important. You have math practices, and we have best practices for instruction. Best practices for instructions are not necessarily tied to math. What they are is they are people kind of pull from the most successful teachers. Well, what methods do they use to instruct? And after research and time and proving over and over again that these methods work, they are then deemed best practices for instruction. There are instructional strategies. So those kind of go hand in hand. So instructional strategies is the larger picture, and best practices are the ones that are research-based, that are proven time and again to work to be able to get students to understand the curriculum, right? And modeling is one of those best practices. And then we're going to do differentiation. And going back to that rigor, where we're going to put in those supports for whatever support each child needs, well, that's what differentiation does. It's meeting each child where they're at. And we're looking at content. What is the information that you are delivering? How do you need to now break that up? Do some students need you to take a step back and fill in some information they didn't really understand from last year? Process. Well, some children aren't writers. So some children learn better by hands-on. Some children, so what is the process? What are the instructional practices that you're going to use? That's not the same for the entire class. It needs to be different in the same lesson. You've got to use different instructional strategies to meet the needs of your students. And then your product. What artifacts are you going to collect that the students are going to create that demonstrate that they understood what you taught? Are they all going to create the same thing? Is that really meeting students where they're at? Is writing a 3-page paper going to be rigorous for one student versus another? No, it's a matter of really thinking of what are the students going to produce to show me that they learned it, and what about this group of students? What do they need to produce? And what about this group of students? What can they produce? That's both challenging for each of them at their own level. So let's look at instructional strategies. Some strategies are think, pair, share. That's where you give a minute to think, they talk to a partner, then they share with the larger group. Everybody responds is another instructional strategy. These are ones that are quick check-ins. Say, okay, so if you understood this problem, give me a thumbs up. If you had some trouble really understanding and being able to explain to your partner why this worked, give me a thumbs to the side, or stand up if you could. You can research it. There are lots of fun and engaging ways that you can quickly kind of glance the classroom. Wait time. If you give a question, give the students to think. Not everybody can think on their feet, so really giving them time to think. Student grouping. I know it's really important to have students in groups, but is it important for everything? They need to be in groups for everything. While we're at work, there's a time where I prefer to work by myself, whereas a time is more appropriate for me to work with others. So you've got to think about the appropriateness of the student grouping and the types of grouping that you want to have. Do you want to have all your struggling students together in a group working with you, and then your higher students working together on another project? Or do you want to group it up where you have some stronger students and some struggling students to kind of so they can learn from each other? There are times that are appropriate for all those situations, and you can't just blanket use it all at the same time. And then graphic organizers. Well, if we want them to see connections and really synthesize the information, well, how am I best going to do that visually? How can the students do that visually? It's keeping their notebooks or keeping their folders. So these are all things that you kind of are important, that are pretty important to think about. Now we're going to move on to modeling. Modeling is basically drawing, and it's not always just, well, draw a picture of what you did. There is a great strategy that comes out of Singapore Math that is called bar modeling. Online, you can look up thinking blocks. That's a great resource to use. And it's paper and pencil, and you get the kids to draw out the problem. Again, there's resources online for you to learn how to do it. And so the first one is fourth, I believe that's a third grade problem. So that's one way to use that. And then by 6th grade, now we're dividing with the bar model, dividing fractions, that is. And now by 8th grade, we're using a model to demonstrate volume of a cylinder. So these are all different methods to um, show what the students know by just drawing things out. So that's another great strategy to use. Now this is another graphic about differentiated instruction. One important thing as you begin your careers in teaching is to constantly at least read one book about teaching per year. Hopefully more, but if this is your first year, it's going to be a lot. But it's very important to read at least one book about teaching just to improve your practice. This is a great book. Carol Ann Tomlinson, she is a guru. She is the guru. She literally wrote the book on differentiated instruction. And again, this graphic kind of goes through what I described about meeting children where they're at and making things applicable and relevant and challenging to at least groups of students, because we can't just use a blanket activity or strategy for the whole class. It's not best for all of them. So you can go ahead and review this when you download the PowerPoint on your own. You can try Googling her book. You might find a PDF of it for free online. I'm not sure, but or purchase the book or borrow it from your library, but it's a great one to have. So then resources. If you go into your schools and you find there's no resources for you, there's no curriculum, there's no pacing guide, I would go here to Engage New York. It's already done for you. Everything is done. You will just love it. It's all there, set and ready. But if you just need some extra support on what to learn or what to do, you can go to Emergent Math. That's for grades 3 and higher. MapShell, that starts at grade 7 and higher. Illustrative Math, that's for all grades. This is where I got the math practices posters. This website gives you videos and more information just to learn on your own. And now these are some supplemental resources. LearnZillion.com, it really gives you some really step-by-step procedural videos on how to model and how to do things if you need a refresher. I would not use these so much and focus on using these so much on my instruction, but it's great to send a link home to a parent if they just need a quick refresher. That's great. Or if you have a practice lesson, you find yourself teaching something a couple of times or not getting it, that would be a great resource to have in your back pocket. MathPlayground.com, I've used this for years. It's a great resource. There's lots of interactive games for most grade levels, definitely for all of the elementary grade levels through grade 8, I believe. Great information. 10 Marks, another great website to really support thinking. And then Dan Myers, if you like his videos and you say, yeah, but I'm not that tech savvy, he's posted his lessons up. And you really don't have to reinvent the wheel. You can go to his blog, look on the right-hand margin, scroll down, you'll see his high school curriculum. So thank you very much. I hope you enjoy the rest of this class and you really have a great time embarking in your career. Thank you.